Yeah, I'm an engineer here on the APM product, and I was the lead for the error page project that you got to see this morning. So I'm going to be talking about that, and I have code samples that are actually from our real code that you'll get to see as well. So let's get into it. First, I should ask, who here has used React? Awesome. Who here has used a Flux implementation? Redux? All right, cool. Well, I think you'll enjoy this. So what is Redux? So broadly, Redux is a Flux implementation. It's very simple. Conceptually, it's very simple as well. So Flux has all these concepts of like stores and dispatchers, lots of them. In Redux, there's only one. And we're going to talk about that in a second. But they spend a lot of time sort of narrowing the focus. It's also, it's inspired by functional programming and mutability. So in Redux, you get things done by not doing anything. And we'll talk about how you do that. Specifically, you get things done by not changing things. And it powers our new errors feature. So here are some links to those things down there. So why Redux? We spent a while when we were working on the design for the errors feature thinking about like what framework are we going to choose. We'd previously done a lot of Angular, and Redux had the best of both worlds in terms of predictable state, immutability, and it was really easy to sort of reason about what was happening, easy to test things. So, and I'd be happy to show examples of testing later. I don't have any of my slides, but I'm happy to talk about that. So, it's also very performant. It's really fast when you structure it in the right way, when you make your reducers lightweight. Everything in Redux ideally is really simple. You have a few things going on, but if everything's really simple, then the browser can make that really fast for you. So I like these things. So let's talk about the concepts. So at the heart of things, there's the store, and that's kind of where everything goes through. Then we have actions, because it's a Flux implementation, and you get those through action creators. And there's reducers that apply those actions. And then middleware is sort of, we'll talk about that in a minute, a way to stitch things together. So the store. The store is just a really simple wrapper around a JavaScript object. The store only exposes two real methods. There are a couple others, you probably won't use them. We haven't used them. There's getState and there's dispatch. And getState just gives you the underlying state of the store whenever you ask for it. And it's really fast. It's just sort of exposing an object it already has, so you can call it as much as you want. It's not like compiling a state. It's not transforming things for you. It's just saying, oh yeah, here's the state. Here's the state. But you typically don't interact with the store directly. So if you're using React, you're going to be using something like React Redux, and it takes care of a lot of that for you. So the store is there. You build it by combining your reducers and stuff. We'll talk about that. But you don't actually like touch it directly because the things that you need from it are handed into your components as props. So that's the store, but I didn't tell you how to do anything. This is an example of sort of how you do something. So here's an action, and we're dispatching it against the store. So let's say that find errors is an action that goes through and for your application sort of queries NRDB and figures out what your errors are and puts that together. So this would be dispatching it. And then if you want to get the result of that, the third line down here shows you how to do that. And this is the one piece of code that is very contrived. So I didn't tell you how to do anything. Actions are how you do that. So at its core, the actions are just very simple JavaScript objects. And I really like Flux standard actions. I think it's a really great spec. And Redux doesn't require that you do that. I would suggest that you do. But the only requirement that Redux has of your actions is that they have a type. And the type is just a simple property on the object. Generally, it's a string. Generally, it's a constant. You're going to be referencing that type a lot. So I'd highly suggest just having like a little constants file that's really simple that has all those. Then when you're trying to get data into your state, you're going to put that in the payload. The Flux standard actions sort of specify the way that should work. actions being objects, it's a little bit boilerplate to have to like create these objects everywhere. So generally speaking, you'll use action creators. So let me just show you what that looks like. So these are two different action creators here. So you can see that this is just a function that's returning an object. So here's my object here, here's type. This, again, is a constant. The value of this constant is actually the same thing. And then in the payload, you can put whatever you want. The payload doesn't even have to be an object. So there are a couple places where the payload will be like true or false for us. Some of our actions don't even have payloads. Like after you add a filter, we want to make sure that we invalidate the current state. So we just dispatch an action that just has that one type of invalidate state. And then we dispatch more actions to fetch data. But that action, for example, doesn't even have a payload. There are two other things that in Flux standards actions you can put on your actions. There's an error and there's a metadata. Error is a Boolean, and metadata is whatever you want. It's exactly like payload. And those are both optional, and they're sort of just a way to help your reducers know a little bit more about what they need to do in a very predictable way. So reducers. So basically, a reducer comes from the functional programming idea of a reduce function. A reduce function takes two arguments. It takes like a memoized value and like a new thing, and then it returns the combination of those. And you'll like reduce over an array, for example, to get a value. So summing an array, for example, would be like a reduction where you start with 0 and you run that for each element in the array, and you return the memo plus the new thing. And here you can see this reduce. This would be like the first line here would be an example of like implementing a counter, where the state is the prior value. So it might be 0, it might be 1. Your state, of course, can be an object or an array or whatever you want. But in this example, let's imagine the state's just an integer. And your action, you don't have to read the action. I'll show a reducer on the next slide, but you can do whatever you want here in terms of reading the action to figure out what to do. The important part is just that you return a new copy of state that reflects those changes. So here we're just returning state plus 1. And generally you'll have like a medium-sized switch operation in your reducer that will sort of dispatch on type. I've got an example coming up. It's important though to mention that you don't want to change the existing state as part of returning a new state. So here's a full reducer. This is actually the reducer that we have in place that when you click on error trace to see an error, this code runs. So we've only got really one thing going on here. We've got this one action of replace error trace that this reducer knows how to handle. So it will only really do its thing for that one action. And what it does is it returns a new state, which is just this object here, where the ID and the body are pulled out of the payload. So it just sort of updates itself. And you can see we're not actually referencing this incoming state because replacing error trace is like a full replace, so we don't need to do that. But if you did want to, you can do whatever you want. But again, make copies of things. Don't change things directly. So how can you do that to make copies? So there's a really great add-on from React add-ons. There's a thing called update, and they're immutability helpers. And if anyone's used MongoDB's query API, you've got sort of the same concerns there of updating like JSON blobs in place, and it adheres to the MongoDB idea of like how these operations work. So what's happening is that running this function against state, which again is the state that's coming in here, we're specifying the things that we want to change. So we're saying here, return a new object that is this, but with the two changes of, for ID, set it equal to this variable ID that we grab from here, and for body, set that equal to body that we grab from the payload. So it's another way to apply those. When you have a larger reducer, this becomes really important. Our reducer that we have that handles the overview page state, so when you're looking at like the big top 5 chart and the 2 little mini facet charts and the heat map, that reducer, it's It's not that big, but it's probably at least like 120 lines of code, and there are a few different parts of like the state department. So it's really important that like when we're updating like one little part of it, we don't change anything else. And we get that that made very simple for us by using this React add-on. You could also use immutable.js from Facebook. It's I'd be happy to talk about that afterwards. We considered it, but it just turned out that we could do kind of the same things in this approach without having to lose the ability to access JavaScript objects directly. So the last thing I'm going to say about reducers is there's a really useful combine middleware function. Combine reducers function that you can use if you want to stitch together a bunch of reducers. So the top level element of like our state and of our reducers is actually the result of that, where we have, I think, 8 or so reducers for the various aspects of the state of the error page, and we combine those all. So middleware, I mentioned that earlier, it's kind of like meta actions. Essentially, it's sitting between, when you dispatch an action, it's sitting between the reducers receiving the action and you're having dispatched it. And that gives you an opportunity to do what you want to do here if you want to dispatch a different action. So you get stuff done here by not changing anything, which is sort of a weird way to think about it. But the thing the middleware can do to change something is to choose not to dispatch the action it received. So it has to sort of pass everything through kind of in the way that like middleware in a web tier like a Java servlet filter or like a rack middleware would, where it has to like invoke call or do filter. And you can choose not to do that here. And if you want to change something instead, you can dispatch a separate action that reflects those changes that you want. And that's essentially how middleware works. But I think the great thing about Redux middleware is you don't have to understand that, because we haven't written any middleware, and I don't think that we will, because there's some existing middleware that handles a lot of the concerns that you would have, and it's very well tested and works great. So you don't have to really go to that level if you don't want to. And those pieces of middleware that I mentioned are Thunk, Redux Promise, and so React has this idea of like batching updates. So when it updates the physical DOM from the virtual DOM, it does that at once. So you get like a nice sort of experience where not everything's changing at once, but it's like one complete change. That's implemented as a middleware as well. It's called, I think it's Redux Batched Updates or React Batch Updates, but that's middleware. So yeah, that's middleware, but I don't have to worry about it too much. So how do you use it? So Redux is built on many great opinions. So I think it's easier to ask that question first in reverse. How don't I use it? So in your reducers, it's so tempting when you're being called in that function, reduce with a state and an action, to just like change the state and return that same object. That's not you don't want to do that. And I can tell you more about that later, but basically it breaks your updates, where your React application might not actually update because it might think that it's already applied that state when it hasn't. And the reason why it thinks that is because it's not actually a new state. It's the previous state that's been corrupted. So that's something you don't want to do. So reducers need to be free of side effects in that regard. Another thing you don't want to do, kind of in that same vein, is it's so tempting when you have the store to just say get state. And then once you have that state, it's just a regular JavaScript object. You can do what you want with it. Don't change it. Change it using actions to get the effects you want. And you'll run into that exact same problem I just described if you do call get state and then change that value. Then the main thing I would suggest not doing is storing mouse positions and hover in Redux, because that'll often trigger like an entire re-render of your application tree. And it could just be so silly when someone's hovering over the heat map and like their browser's just chugging along. We did that for like a couple days, and we realized that kind of state doesn't belong in Redux. The way we handle that is with React set state. We try to keep those tiny little trivial bits of state that you don't care if they're persisted. We keep those local to the components, so those don't go up the application tree. So like hover state, we use set state for that, or like when you're deleting errors, for example, there's a modal that pops up. The point at which you're at on confirming and all that, that's just like a local set state inside of that modal. So the idea here is if there's something that like, a piece of state that you want to be remembered across page refreshes, or like if I send a link to a colleague and I want them to have that piece of state so they see the same thing I'm seeing. That belongs in Redux, and that belongs, for example, in like Redux router in your URL or something like that. But if it's something as trivial as like hover state, don't put that in Redux. So this is how you can use it with React. So there's a great library from the exact same guy who wrote Redux called Redux React that essentially lets you decorate your components with a wrapper so they'll receive state changes from the store. So what's going on here, I'll walk you through it, is this is a regular React component, and there are some prop types. So these are the pieces of data that we want. So this is the code that on the error page wraps the top 5 chart. So this is how we get the data for that top 5 errors chart. So there are 3 pieces of data we care about. We care about the overview chart data, which is essentially the result of running the query against NRDB. Then we care about your application events. So that's essentially what you would get if you were calling the alerts API to say what's the state of this application's health. And then we also care about a pinnable query, which is sort of a form of the NURCL that you would run to get this. And we care about that so we can send you to insights to explore your data further. And this is how you get that data. So the overview chart data is pulled out of the state from these locations here by running this select function. And this just returns an object that maps to the prop types. And Redux React does that on your behalf when you create a connected component. So you invoke this with a function. So this right here is referencing this function. And it will wrap your component in a higher level component that will listen to state changes and execute that function and update the props for you. So it's this great way that you don't really have to think about it. And you do end up with a little bit of boilerplate like this, but if you're doing anything serious here, there's a good chance that you've got a better abstraction coming and you can refactor that somewhere else. We found that all of these sorts of wrapper classes look exactly like out of time a little bit, but we had some higher level functions for using funcs to like fetch data. So this is an example where you can have actions that dispatch actions. So this is how we update your stored attributes on that trace table, where we will take like the attribute you want to sort by in the direction, and then if it's different, we'll dispatch these actions to make those changes happen for you. But it's great that it's idempotent and self-throttling here. If you're already doing what you want, we just do nothing. And I would suggest using that approach as well, so that you can dispatch actions sort of whenever you want, and they can cancel themselves. And this is using Redux Thunk. So that's a quick overview. I'd love to answer questions. I'll be working at the APM booth right after this, and also tomorrow afternoon. So I'd love to talk about the APM product or the errors page or how we built it. I don't know if I have time for, so I'd be happy to answer questions at the booth.